Hi everyone, thank you for tuning in. In this video, we are actually going to be taking a look at Washington bike demand prediction, where we try to predict what can be the demand for the various bikes in different instances of time with the help of machine learning and data science. Remember that this was the data that was taken for the state of Washington, but we can slowly expand it to other areas as well. The first thing that we do is to take a look at the business use case. It is always important to consider how much of an impact does a machine learning model have on the business. We have companies such as Zagster and Lime Bikes, or also Blue Bikes in the US, that give services to a lot of people. But the thing or the challenge that they're facing is they do not know how many bikes to place at a particular point so that people can access them regularly. There can always be instances where a lot of people might be looking for bikes, but they have less number of bikes during that time, and vice versa. It is in this case that we are basically using machine learning and data science to actually solve this problem. And let us also see some challenges that we have already discussed, right? We use machine learning, data science to understand hidden patterns and trends from the data, followed by exploratory data analysis, which is usually the first step in machine learning. Exploratory data analysis is like visualizing our results and seeing which of these features are actually important, or if there is any correlation between various features, we also take that into consideration. Followed by, we should also divide the data into two parts, which is the first step. We divide the overall data into training part and the test part. Usually training part contains around 80% of the data, whereas the remaining 20% is the test data. We always evaluate on the test data about how our machine learning model is performing. We have metrics such as mean squared error and mean absolute error, which are often used for regression tasks. Followed by, we look at machine learning models such as deep neural network, k nearest neighbors, partial least squares regression, or it is also known as PLS regression, a decision tree regressor, a gradient boosting regressor. We also take logistic regression followed by long short-term memory. And finally, we take a look at all of the outcomes from this project, where we consider metrics like mean squared error and mean absolute error. We also use models like gradient boosted decision trees and deep neural networks, and they were actually able to perform better than the other models that we have seen above. We did the exploratory data analysis. We would find out which features are really important. We also take a look at the future scope of the project. Adding features such as connectivity score and people's perceptions about the environment can also have a huge impact about the demand for the bikes. Furthermore, we will also try to deploy this in real time to see how well these models are actually performing. Users can actually use our product in the long term as well because of this. Okay, now let us get started with the project. I have loaded this in the Jupyter notebook, which is a very friendly tool for data scientists and machine learning engineers. These are the metrics. This is the source at which you can find the data. This is the introduction metrics, and here are the list of all the tables or titles that we have, and followed by machine learning analysis. We also do have the conclusion. We are importing a list of all the libraries that are important for machine learning, and also we import libraries such as Seaborn and Matplotlib. Reading the data, which is the first step, we take a look at the description of the data to find out the mean values for every feature. We also take a look at the holidays, whether because a holiday can also affect the demand for the bikes. Similarly, we also convert a few features. We try to extract the day from the date time object. We also extract different things, whether it was spring or whether it was fall, from the dates. Furthermore, we take a look at the count plots and see the demand for the bikes. we see that during the fall we had a large count of the number of bikes compared to the spring or the summer. This is the exploratory data analysis thing that we do, and we also see the demand for the bikes during different seasons. We see that during the fall a lot of people have ordered the bikes or have been using the bikes. Similarly, we take a look at the total demand. We also see that it's in the fall that was the highest demand. Taking a look at total values present for different months, we see how it is actually divided, followed by how the demand has been for different months. We see that September had the highest average demand for the bikes, followed by June. The lowest demand had been in the month of January. We also take a look at the wind speed distribution, followed by the distribution of the temperature, and this is what we basically do to predict how the bikes are going to be sold at. We take a look at the total demand for the bikes during different hours of the day, and we see that 18th hour or the 17th hour has the highest demand, which is nothing but at 5 p.m., where usually people go out from work. And we take a look at the humidity values, we take a look at the scatter plots distribution, we take a look at the few other scatter plots, we try to segment the data and based on the temperature. Similarly, we do the line plot to see the demand for the casual riders and the average riders. This is all exploratory data analysis, and then we perform feature engineering just to see how the demand for the bike has been. We see that there is some seasonality, there is some trend in this data that we would have to address. We also use simple LSTM models just to predict in the future how many bikes do we need to place on that particular location. And we do a pretty good job because using LSTM we are able to get the model prediction versus the true prediction to be very close, which is really good. And this is the step. We also divide into different trends patterns to see. LSTM is a deep learning model which can really be used for our analysis. Now let us also take a look at various machine learning models that we use. We used a deep neural network, which was the first step. We trained for different epochs, and finally we are able to get a mean squared error of, I think this was trained for many epochs. Finally we get the mean squared error to be around 1300 and mean absolute to be 24, which was not bad. And we take a look at the scatter plots just to see the presence of how good our predictions are with the actual ones, which was really good. We use the k nearest neighbors, and we also take a look at the predictions. I think the k nearest neighbors wasn't doing that good. We take a look at PLS regression, and we calculate the number of missing values in the data and the total number of principal components. We also use decision tree regressor just to see how each of these components are influencing the mean absolute error. I think the decision tree regressor was doing really well because on the y-axis we have the predictions, on the x-axis we have the actual data. We see that there is a pretty significant overlap between these two, and we can just draw a straight line, which means that predictions are not far off from the actual values. Finally, we do gradient boosted decision trees, and logistic regression was also the step. We have seen how we started with the machine learning problem by understanding the business requirement, followed by exploratory data analysis, which was the first step. We also performed feature engineering, where we have extracted dates from the column and also other features like the spring or the fall, followed by machine learning analysis. We just test various models and look at the right plots before we can actually come up with the best machine learning model which can be deployed. Thank you so much for tuning in. If you have any questions, feel free to reach out and comment down in the code cell below so that I would reach back to you anytime. Thank you.